Okay, so we are finally ready to do the interesting bit, which is solving a system of equations using matrix. So in this video, I'm just going to solve a 2 by 2 system, and then I'm going to leave the 3 by 3 system for a practice problem in a later video. Okay, so for now, let us go back to the very first system of equations I had introduced, which is this. So 2x plus 3y equal to 8. Let me write that down. 2x plus 3y equal to 8, and 7x minus y equals to 5. Now, of course, we had already solved this. We know that x is equal to 1 and y is equal to 2. But remember what I talked about, that in real life, you're hardly ever going to be working with a 2 by 2 system of equation, two variable two equation. You'll be working with much larger systems, 8 by 8 system, or 10 by 10 system, well, maybe even a 50 by 50 system, why not? And when we end up in situations such as that, it helps to know how to solve that system of equation using matrix. So in this course, we are not going to go over the 3 by 3 case. In your assignment, you will be solving a 4 by 4 case just for practice. We are not going to look at systems larger than that because it's a bit of a tedious process and you won't have enough time during an exam to solve it. But the important thing is, once you learn how to do the process, you will know how to solve a 50 by 50 case. It's going to be tedious, it's going to be long, but you will know the process. Okay, so let's try and solve this 2 by 2 case using a system of equations. And so instead of keeping it in this form, I'm going to convert this in the matrix form. Okay, so tell me if this makes sense to you guys. I'm just this should make sense to everyone. So this is a 2 by 1 matrix. This is a 2 by 1 matrix. And so there's really no difference between this and this. All I'm saying is that 2x plus 3y is equal to 8 and 7x plus y equal to 5. I've just done it together. From here, I'm going to write, let me use the red ink. I'm going to write 2, 3, 7 minus 1 x, y equals to 8 by 5. And when I wrote this down in the first lecture, it wouldn't have made sense to a lot of you all, but let's take a look at it again. So this is a 2 by 2 matrix. This is a 2 by 1 matrix. This is a 2 by 1 matrix. Okay. Now, we know matrix multiplication. So if we multiply these two matrices, okay, what are we going to get? We're going to get, I'll write it on this side. If we multiply this, what am I doing? Okay. If we multiply this two matrix, what are we going to get? We are going to get 2x plus 3y, and we are going to get 7x minus 1y. So make sure this makes sense to everyone. But okay, so this right here, this is the matrix form. So this is our system of equation, and we have converted that system of equation into the matrix form. And now that we have a matrix form, we can solve this using the matrix inversion method. So suppose I say A is equal to 237 minus 1. X is equal to X and Y is equal to, you can call this anything. Let's call this B. So what we have is AX equal to B. And remember what we have already talked about is that if we were doing simple algebra, what we would just do is A by AX equals to B by X. This and this cancels out. X equals to B by A. But for matrix, we cannot do that. So what we have to do is A inverse AX equals to A inverse. We're multiplying both sides by A inverse. This becomes I, an identity matrix, equals to A inverse B, and that gives us the answer. This is what we want. This is where we want to arrive at. To get that, we know X, we know B, we have to calculate A inverse. Okay, so let's try and do that. A is 2, 3, 7 minus 1. And we have learned today how to invert a matrix. I'll order this. I don't know how they got here, but they did somehow. Okay. So first thing, let's calculate the determinant of A, which is 2 times minus 1 minus 7 times 3. So that gives us minus 2 minus 21, so minus 23. Next thing we need to do is, what was next? The minor matrix. Then we have to calculate the cofactor matrix. We have to calculate the adjoint. And then finally, we can calculate A inverse. You guys do all the steps. I've been doing this for 10 years, so I know a shortcut which I'm going to use. You guys, please don't try to do what I'm doing. Go through the usual route. Okay, so A inverse gives me this minus 1, 2, minus 3, minus 7. Okay. If this is A inverse, and this is what we need, therefore, X equal to A inverse B. Remember, X is a 2 by 1 matrix of basically XY equal to and B is also a 2 by 1 matrix of right here 8, 5. Okay, so a bit of multiplication. We're going to leave this outside and multiply. Before we multiply, once again, let's check for conformity. 2, 1, 2, 2, and 2, 1. So this and this are the same, which means they conform, which means we can multiply them. If we multiply them, what we get is minus 8 minus 15 minus, how much would this be? 56 plus 10. So that gives me minus 1 by 23 minus 23 minus 46. And then if we multiply it with the scalar outside, I get 1. And of course, on this side, I have xy. And there you have it. We have solved a system of equation using the matrix. Basically, what we know is that, once again, is that x is equal to 1 and y is equal to 2, and that's it. That's the end of matrix inversion.